Hey guys, if you're looking for detailed information related to the new digital SAT, this is the video for you. For this video, we're going to be focusing on the math topic of lines, angles, and triangles. Please note that this geometry-based question or types of questions are very difficult based on past prior exams. Please also note the disclaimer below. If you're focusing more on types of questions that you could see on this topic, make sure to stick around till the end of the video. So let's get started. Let's first talk about angles. I understand this topic is lines, angles, and triangles, but I like to cover angles first just because it helps you understand the way that lines really work around angles. So the first thing that you want to note with angles is that you're going to have them historically measured in degrees. So I just want to point that out when you are reviewing a problem. Now, let's first focus on the different types of angles that you could see. If you're given a diagram that looks like this, and there is a 90-degree angle, and there's a line that sort of intersects between them, the two angles, angle 1 and angle 2, are considered complementary angles. What that means is if there's two angles and the sum of those angles equals 90 degrees, then we call them complementary. For problems, you can see the term complementary in there, and if that's the case, that's your notation to understand that they're talking about two angles that equal the sum of 90 degrees. So make sure that you recognize that term. If it's supplementary, they're letting you know that the angles involved, which are usually a pair, so angle 1 and angle 2, are going to combine, and the sum of those two angles are also going to be 180 degrees. Now let's talk about the different ways angles can be represented if there is no split between them. So if you just have an angle and it's greater than 90 degrees, to 180 degrees, we call that obtuse. You want to think obese, obtuse, they sort of sound the same. They're going to be really, really large. And if it's 90 degrees, which they'll give you a little 90-degree symbol, or they'll let you know it's 90 degrees, that's just a right angle. If it's 180 degrees, they're letting you know that's a straight line or a straight angle. And if it's less than 90 degrees, we're talking about something that is acute. So that's going to be an acute angle. Now, let's focus on the ways that lines can intersect and cause some sort of angle measurement relationship, which you are expected to know. So I want you to take a look at these two lines that go ahead and intersect with one another. So this is where lines intersect with angles in this topic. So first we can have what we call vertical angles. So that is when you have this crisscross shape, and we know the angle measurements are going to be exactly the same if they are opposite to one another. So for example, angle 1 and angle 3 are going to be the exact same measurement. So if this is 30 degrees, then guess what? This is 30 degrees as well. Also, based on this information, we also know that angle 2 is also going to be equivalent to angle 4. So I also want to point out that you could be given information related to this. So for example, you know that the following is going to be a line. So this is a line. And if you know that's a line, based on our understanding of what lines are, we know that a line is going to be 180 degrees. If we go ahead and subtract this 30 degrees, and of course you could use a calculator to help you solve, you know that this is going to be 150 left over. So angle 2 by default is going to be 150, which also means that angle 4 is also going to be 150. And so that's a way that they could test you in terms of vertical angles. They won't really tell you that it's vertical angles. They'll instead give you a diagram like this and expect that you know that the opposites are going to match up, and that the two parts, so 1 and 2, 3 and 4, that a line adds up to 180 degrees. Now let's talk about adjacent angles. So adjacent angles are what are going to be next to each other, tending to be 180 degrees in this shape. So we stepped ahead and said, like, for example, angle 1 and 2 are going to be adjacent angles, and they're also 180 degrees. Angles 2 and 3 are also going to be adjacent angles and are also 180 degrees. Then we have angle 3 and angle 4. Those are going to be adjacent as well and equal to 180 degrees. And 1 and 4 are going to also be 180 degrees. So that's the difference between vertical angles and adjacent angles and how that relates to lines. Now we're going to focus on the differences between alternating interior angles and alternating exterior angles. For this difference, it's really hard to explain it in the forms of a definition, and I have these two definitions here, and I feel like it's very confusing for students, so I like to use a diagram to help you understand. Please note for the new digital SAT and PSAT and in past exams, they don't come out and say, hey, here's a problem with alternating interior and exterior angles. Instead, they give you a diagram. The most common type of diagram that I've seen before I should say, is one similar to the one listed here. So we're going to go ahead and tackle a problem together. If they give you a word problem with these types of angles, majority of the time they tell you just one angle and you're expected to fill out the rest of the angles. And you're going to be able to do that. Please note that there is an intersecting line between two parallel lines that exists. And I want you to keep that in mind when we're going through the problem together. So first of all, let's say that they told you that this side is 30 degrees. We know that based on alternating angles that the opposite side is also going to be 30 degrees. And because of this, we can go ahead and find this angle measurement as well by going ahead and stating that this is a line, and we know that lines have to be 180 degrees. We can go ahead and then subtract 30 to figure out the leftover angle measurement that's here. So we can go ahead and say that is 150. Of course, you can use your calculator to solve, but I just wanted to show it out here just so you could see that 150 plus 30 is going to give you 180. So we now have 150 that's listed here. I should use a different color so you could see a little bit better. So it's 150 over here. And we can go ahead and say by the alternating angle rule that this side is also going to be 150 degrees as well. Now, you can see that there are interior angles here, and this is where alternating interior angles comes in. And that says if the one interior angle is 150, opposite to that angle is going to be exactly the same. So this is going to be 150 degrees. And we could say the same for the opposite side for the interior angles, that if this is 30, guess what? This is going to be 30 as well. And based on alternating exterior angles, if this is 30, we could say that this is 30 as well. And if this is 150, we can go ahead and say that this is 150 as well. So you don't need to know the definitions of the words, you just need to know how to apply them for the problem. But I like to use it with a diagram like this to see how you can break that down. And as stated before, they'll give you a problem, they'll let you know one angle measurement, and then you're expected to solve for one of the other sides, and they usually represent it with some sort of variable. So they'll say, find X degrees, and you have to go ahead and play around with this. And because this is the digital SAT, I always tell students, guess what? Pretend that you're writing it out and see if you could try to fill in so you could see how to visualize the problem yourself. Okay, I hope that helps understanding the difference. Now let's talk about angle bisectors. Now an angle bisector is just a term that you need to note is when you have an angle. So that's going to be the big black here. And that black angle is split by this red part right here. and that is called the angle bisector. The angle bisector is a line that splits the angle into two equal measurements. So if they say, guess what, the angle of the big giant one here is going to be 60 degrees, and there was an angle bisector that split it up, now you know that you can solve and say, guess what? 60 divided by 2 is 30, so each of these sides are going to be 30 degrees. Okay, let's talk about the topic of midpoints. Now, we've talked about midpoints before, or you might have heard about midpoints when utilizing the midpoint formula in the algebra portion of the digital SAT or digital PSAT. In terms of understanding it in geometry, you're just focused on this idea that there could be a line. So in this case, we have line C, and the midpoint is going to divide that up. So it divides it in half between part 1 and part 2 of a line. So if you're going to look at it more in terms of a line that's not as complex as this, we can go ahead and say, okay, we have this line, and I'm going to draw a better line here. And we're going to go ahead and say, guess what? We need to split it in half, and the midpoint will split it midway in between. Then we know the angle measurement of this side and this side will be exactly the same. So that's what a midpoint of a line is going to be. Okay, so now we're going to talk about triangles. Please note for the digital SAT, there are two subtopics related to triangles. This is the first topic, and then there's another topic related to triangles, which is titled Right Triangles in Trigonometry. You could actually find the video as well if you go into the playlist titled Digital PSAT and SAT for the understanding of right triangles and trigonometry. For this topic, I'm going to focus on triangles in terms of information that you need to know related to angles, and that way you can understand both in pieces of information. The first thing that I want to note is the different types of triangles that you see on the screen here. You have the Pythagorean theorem, which is a squared plus b squared equals c squared. I want to note that if they give you a triangle in general, let's forego this formula here. And they give you a little line indentation like this, and they went like this, and they went like this. And they said that there's one line here, two lines here, three lines here with these little indentations. This is just to let you know that this is the smallest side and this is the biggest side, and there are three different angle, or I should say different line measurements. I want to note that as well. I want to also go to this triangle picture here where they let you know that the angle measurement here and the angle measurement here are equivalent or the same, which means that opposite the sides of these are going to be exactly the same. So that means, let's say that this side is the measurement of 2 for some reason for the length. That means that this side also for length will be 2. So let me just repeat that again. If you see these little indentations here, this is to designate a piece of information based on the length of the line on the triangle. So in this case, let's combine all that we know together. We know that this is 60 degrees, 60 degrees, and 60 degrees, which adds up to the total of a triangle's degree measurement, which is always going to be 180 degrees. We know that all sides of an equilateral triangle, which by the way is covered more in depth in the other video, that means that it's all going to be 60 degrees on all sides if it's an equilateral triangle. Because the angles are exactly the same, that also means that the sides are actually the same in terms of length. And that's why these two little line buttons, I'm going to call them, are exactly the same because they're letting you know, hey, it's the same, not different. So if they tell you, for example, that, this is one line designation and this is a 2-line designation and this is a 3-line designation, that means that all sides of the triangle are exactly different, or I should say are different. They're length is going to be different, which means that the angle measurements are also going to be different as well. So I just want to note that as well. For the digital SAT, you are given a formula sheet that has the formulas related to the 44-45 triangle and the 30-60-90 triangle and the Pythagorean theorem. So you don't really need to commit that to memory for the digital SAT because that's provided on the formula sheet. Let's take a moment and try to solve a quiz question together. Now, there's a question here. I want you to take a moment, read the following question, and try to attempt to solve the question with the picture below. Please pause the video, and once completed, unpause the video so we can review the answer together. Okay, now that you're done reviewing the question and potentially solving it, let's try to solve the problem together. Did you get the answer of 77? Let's try to see how we can attain that answer together. Firstly, we see here in the picture that they go ahead and tell us some degrees. And I also want to point out the following information in the prompt where they tell us that there's intersecting lines U, V, and W. They don't go ahead and label that, and that's okay. You don't really need that information for now. For now, what you're expected to know is that they went ahead and gave you some details and they want you to solve for the value of y. We know that the following here is a triangle, and there are some lines that go ahead and intersect in that triangle that formulate also a line. So we know that the angles of a triangle have to equal 180 degrees. And we know that there is a line here and they give us 112. So we can go ahead and solve the angle listed here by subtracting 180 degrees minus 112 degrees, and that will give you 68 degrees. So we know that this is going to be 68 degrees. So 68 degrees is going to be the angle that's listed here. We also have 35 degrees, and we know that this is a triangle. So we know that we can add these two values together, 35 and 68, and subtract from 180 degrees to go ahead and find that third angle. So you can go ahead and say 180 minus 35 plus 68, and that will go ahead and give you 77, which is the value of y. Just a note that if you're using a calculator, please make sure to use parentheses around these two values to go ahead and subtract from 180 degrees, as it might alter your answer if parentheses are not placed in your calculator. So once again, the answer in this case is 77 degrees. If you like questions like this or you like this topic, make sure to check out the bio, which has several links for the new digital SAT and multiple choice questions and grading questions that cover this and other topics. And they might be coming down the pipeline as well, so just be aware of that as well. We hope that you like this video and make sure to hit that subscribe button because we're going to go ahead and cover other topics in later videos. Hey, Geeking Out on STEM family, guess what? We want you to hit that subscribe button. Why? Because we'll be producing more content just like this for the AP Biology exam and the new digital SAT exam. By subscribing, you'll be getting exclusive, up-to-date tips, tricks, and secrets for both exams. Also, if you're a parent, a teacher, a homeschool instructor, or a student, you might be looking for affordable and exclusive digital products to help improve multiple choice questions, free response questions, or question bank questions related to both the digital SAT or AP Biology exam. We have them here. Make sure to check out our link tree in our bio for curated resources that you won't find anywhere else. These unique resources are designed to help you raise your score. By hitting the subscribe button, the more subscribers we get, by the way, the more videos we can make. So make sure to join our family to ensure that you get a perfect score for both exams. We can't wait to help you succeed.